Okay, part 2. This is numbers 11 through 20. BC practice test. So this is a good example of the kind of integral where you look at this and you're like, oh, what should I do? Well, so the first thing you consider is is this just a thing that I'm supposed to recognize? You know, kind of like the 1 over 1 plus x squared. You're like, oh, that's tangent inverse, something like that. Pretty clearly, no, that's not what's going on here. So then the next thing you want to consider is u substitution. You can never do a u substitution with the top of something. Well, this isn't entirely true, but if this were going to work as a u substitution, the most likely thing would be that you would try to substitute the bottom. And then if you're kind of sniffing around this and you're thinking, well, maybe u substitution would work, whether you write this down or not. If u was equal to, sorry, let me try that again, e to the x minus x, then du would be e to the x minus 1 dx. And then you're like, oh yeah, look, there it is, right there. So that is the correct move. Now, if u substitution doesn't work, only then is when you would consider integration by parts or partial fractions. So I think that's the little thought process that you'd go through there. Anyway, now that we've got the u substitution worked out, let's do it. So the rewrite of this would be like the new u numbers would be, let's see, e to the 0 is 1 minus 0 is 1, and then e to the pi minus pi. Right, those would be the new u numbers. And then here, this turns into 1 over u du. So that's just natural log absolute value u from 1 to e to the pi minus pi. And that looks like it's going to be this. No? Wait. Oh no, just kidding. Because the minus 1, I plugged the 1 in, the natural log of 1 is 0. So it's not, well, how did I get that? No, it would have been, but it's this one, right? Because when I plug that in, I get natural log e to the pi minus natural log of 1, but natural log of 1 is 0. So it's that. All right. Number 12. The table above gives selected values to the differential in which the following intervals must there be a number c such that f prime of c equals 2. I hope that that puts you in mind of the mean value theorem. There must exist a c such that the derivative equals 2. So what does the mean value theorem say? It says average slope equals the actual slope or the derivative on some point in a closed interval if f is differentiable. And notice that they're saying that they have to say that, or we cannot invoke the mean, the mut. That looks like a u, the MVT. So what we need to find then, if the actual slope is 2, we need to find some interval here where the average slope is 2. So let's see, from 0 to 4, the average slope is negative 2. So that's no good. From 4 to 8, the average slope is rise over run is looks like it's a half. Oh, that's no good. From 8 to 12, it looks like we got 8 over 4. Oh, that looks good, right? The average slope would be 2 there. And then this is, I don't know what that is, but it ain't 2. Negative 9/4. So there it is. Let y equals f of x excuse me, be the solution to the differential equation this, with initial condition that. What's the approximation found by doing Euler's method? I love Euler's method. It's so fun. X, y, dy dx, and then the change in y is equal to dy dx times whatever my delta x is. Now I'm going from the point 0, 2 to funky. They want me to go to negative 0.4 with 2 steps. So that would be the other step. And my delta x is, I'm stepping by negative 0.2. That's a little unusual. The most common thing I think we've seen from College Board is that we step up by a half and go from like 0 to 1. But this is stepping down by negative 0.2. So let's see what we can do here. So here the derivative is x plus 2y. X plus 2y, that would be 4. And then to find the delta y, I multiply that times this. So 4 times negative 0.2 is negative 0.8. And that's my delta y. So I add that to this. 2 minus 0.8 is 1.2. And then x, that would be negative 0.2 plus 2y, which is 2.4. So that's 2.2, right? And then I have to multiply that by this. Yikes. Okay, so I guess that's negative 0.44. And then that's my delta y here. 1.2 minus 0.44. This is pretty heavy without a calculator, huh? Is 0.76. So, well, there it is. That's pretty heavy lifting without a calculator from College Board, but there it is. There's Euler's method. Sometimes you have to do math. I would certainly, up until the point where I got an answer that was there, I was feeling not super confident because of how messy the math was getting, but that sure enough is the right answer. What's the slope of the line tangent to the curve this at the point this? Okay, so just going to take the derivative of this. This is implicit differentiation, section 4.1, if you need a review of that. I don't think you're probably good with this. So that's x to the 1/2, so 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 times dy dx equals 0. Okay, so going to plug these things in. This is the same as 1/2. Now x to the negative 1/2. The 1/2 power takes the square root of something, so that's 3/2, and the negative turns it over. That's how exponents work. And here, this y value, the square root of 1/4 is 1/2, and the negative sign flips it over. So this is 1/3 plus dy dx, because those cancel, equals 0, so dy dx is negative 1/3. Got a little improper integral here going from 1 to infinity. It would be mean for them to do this, but they could give an integral that that's an improper integral because it crosses over a vertical asymptote or is up against one. So just looking at that real quick, that's not the case here. We're good. The only issue in this function would be negative 3, and that's not in the 1 to infinity interval. Excuse me. All right, so what are we going to do here? I think I need to do a quick u substitution here just to get this to be not x plus 3 on the bottom. So du is just dx, so it's just a straight swap, but I'm going to move the 6 to the outside. So the 6 is on the outside, and my new u numbers will be 4 to infinity. And on the inside, I now have u to the negative 3/2. That's more calculus-friendly way of writing that. And so that's 6. The antiderivative of u to the negative 3/2. Bump the exponent up 1. and then divide by the new exponent. So that's the same, dividing by negative 1/2, same as multiplying by negative 2. And that's just a constant, so I can put that on the outside with the 6. Okay, so that's negative 12 there, and then the square root, this is u to the negative 1/2 is square root on the bottom, so 1 over the square root of infinity minus 1 over the square root of 4. Yes? Yes, and this goes to 0. If you end up with just a straight up infinity here that's not on the bottom of something, then that's when you would get divergent. But this looks good. So I have negative 12 times negative 1/2, which is positive 6. Okay. If dy dx is this and y is 1, when x is 1, then y equals. Okay, so I want to solve this differential equation. So the only way we know how to do that is separating, and you can't separate by addition and subtraction. You can't add the y over to the other side. That does not work, because then you wouldn't have like times dy. You'd have like plus dy, and that's no good. So I have to move the whole thing over like that. The antiderivative of this is natural log of 2 minus y, but there's a negative sign on the y, so that comes out there. That's the easiest mistake to make, or most common that I've seen. And then the antiderivative of 1 is x. Don't forget the plus c. And got to move that to the other side, so natural log 2 minus y is equal to minus x plus some other version of the constant. You can call it c1, whatever. And I haven't solved for it yet, so I don't have to do minus c. You know that game. And then I do e to the each side of that, so that's 2 minus y is equal to e to the negative x. And you can move the c down here if you like. So y is equal to 2 minus c e to the minus x. And I know that when y is 1, x is 1, so solving for c now. So, oh, where'd my c go? Sorry, c right there. So let's see. That means if I subtract that over here and then flip the signs, I think I get that. So c must be equal to e, right? Because e times 1 over e is equal to 1. You can do other math, divide by that, whatever you want, to get that. And that means, let's see, y is equal to 2 minus e times e to the minus x. And that's e to the 1. So I think that that's the same thing, right? E to the 1 times e to the minus x is e to the 1 minus x. So I guess we would have got there a little bit more directly if we had left the c up here and then solved for it that way. But that's all. That's all good. And of course, if it was free response, that's a perfectly legit way to write the answer. That's 16 is B. Number 17, which one of these following series converges? Okay, this one here, first thing I'm going to do is see what the terms are doing. Here, the terms approach 1, so no chance. Here, the terms approach 1/2. I mean, these are all alternating, but that's not enough if the terms aren't going to 0. The terms have to be going to 0. No chance. This is a question that is about the alternating series test, right? N squared over, so nope. Those terms are going to infinity. So that's like really no chance. And here, higher powers on the bottom, n to the 1, n to the 1/2, so the terms are going to 0, and it alternates. So that's going to converge. Number 18, polar curve action here. First and second quadrants, and we want the area between the two polar curves. This is one where, remember how polar area works. You got to think polar here, and look at these slices. So this is like an outside curve minus inside curve kind of thing. So it's not going to be this, right? Outside minus inside. And the way that polar area works is it's 1/2 integral r squared d theta from theta 1 to theta 2. So I don't know what these are, but they don't have the theta squared, the function squared. So this is the only thing that's even like possible at all. And just to make sure that it's right, going from first and second quadrants, so 0 to pi, that's good. And the g function, is that the one that's really on the outside here? We could check and see what we get when we plug in, like pi, for example. Do we get -2 for the g function? When I plug in pi, cosine of pi is -1, so 4, yeah, that's right. Yep, so when I'm looking in that direction, I get 2. And do I get 0 for this one? Yep. So it's that. That's a pretty easy polar area question. You're not going to find one, I think, that's much easier than that. Now you can look at that and be like, oh, polar area, so hard. I'm just going to guess. Don't do that. It's an easy question. Which of the following statements about series, this series, is true? Before I look at them, I'm just going to kind of see what I can see about this. This is n to the first on the top, n squared on the bottom. So by limit comparison, when I just have this like polynomial over polynomial type thing, this is like, without the sign alternator here, this is like 1 over n, the harmonic series. Right? So that means if it wasn't alternating, it would behave like the harmonic series, which diverges. But it is alternating, so it's going to converge, but it's going to be convergent, right? So the series can be shown to diverge by comparison. Well, that's not true. I mean, the comparison with this is the right thing to compare it to, but it doesn't diverge because it's alternating. The series can be shown to diverge. No, thank you. By limit comparison. We'll talk about the difference between those two in just one sec. The series can be shown to converge by comparison with 1 over n squared. No, that's the wrong thing to compare it to. The series can be shown to converge by the alternating series test. Yes, because the alternating series test says all you need for convergence is terms need to be going to 0 and the signs have to be alternating. Didn't we just do a question about that? That seems weird to me that there's... Yeah. I feel like this question was also about the alternating series test. Oh well. That's interesting. I don't think I've ever seen that, like 2 questions about that so close to each other, or even in the same set of multiple choice. So that is the correct answer. And what's the difference between comparison and limit comparison? Limit comparison is where you take something like n cubed plus blah 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 blah, and then 4n to the 5th plus blah 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 blah, and you just look at the highest powers and you say, oh, this is like 1 over n squared, which converges because it's a p-series with p greater than 1. And the comparison test is where you say, I have a series where I know that this series, let's say from n equals 1 to infinity, converges. And then I have another series where I know that every single term of this other series, b sub n, that they're all less than the terms of a sub n. Then you can say that this series converges because if this one converges and all of the terms of the b series are less than the ones in this, then that also has to converge. We see questions about that sometimes. Pretty logical. All right, this integral and this integral to different functions f and g, which of the following cannot be determined from the information? Can I figure out what this is? Yeah, and it's 2, right? It's just the backwards version of that. So that's not the right answer. Can I figure out what that is? The 3, yeah, the 3 just comes to the outside, so that would be equal to 24. Not that we need to figure out what they're equal to, but why not? Do the rules. The product, we don't have a reverse product rule that just tells us what this is, so wouldn't know about that. If you are trying to find the antiderivative of a product, that's when you do some kind of integration by parts. And I definitely don't have enough information to do anything like that. I'd have to do like the u is equal to f of x, and the dv is equal to g of x, so I'd have to know like the antiderivative of one of either this or that if I switched them, and we just don't have nearly enough information to do any of that. And then this one, you can just split it up into the 3 times the f of x plus g of x, so that would be 24 minus 2, that'd be 22 there. So you can't figure that one.